In this video, we will talk about the resultant and component vectors. Luna gets up from her bed and walks 3 meters in a direction of 36 degrees west of north, and then 5 meters in a direction of 56 degrees south of west. Determine the magnitude and direction of Luna's position from her starting point. In order to solve for the resultant vector, let's first find the components, which are the vertical and horizontal components of the displacement. So for the horizontal component, just gather the given values, which is the 3 meters and 5 meters. So for x component, let's use the function cosine. Cosine, then put the angle of 3 meter, which is 36 degrees. Then for 5 meter, cosine and its angle 56 degrees. Then just simply type this in your calculator and you will get the value. So simply add the values in the x component. We will get 5.23 meters. Okay, let's proceed with the vertical component. We will use the function sine. So just like before, write down the given values. 3 meters sine 36 degrees, 5 meters sine 56 degrees. So again, just put these values in your calculator and you will get the answer. So simply add these values. We will get 5.91 meters for the vertical component. Therefore, the horizontal component is 5.23 meter and then the vertical component is 5.91 meter. Then we can proceed in determining the resultant vector. For its magnitude, we will use Pythagorean theorem. And for its direction, we will use the trigonometric function. First, draw the diagram. We have the x and y component. So this. Then draw the vector, a new vector from the tail of x component to the head of y component. So as you notice, a right triangle was formed. So by using the equation r squared is equals to a squared plus b squared, we can determine the magnitude. So the and stands for the resultant vector, then simply substitute the values of x and y components. So we need to cancel the exponent of the resultant. So we need to square both sides. Cancel, bring down, then we will get 7.9 meters. Therefore, the magnitude is 7.9 meters. Next, as I said earlier, in determining the direction, we will use trigonometric function. So let's draw another diagram. In this case, this is the opposite side, the adjacent side, and the hypotenuse side. And from the diagram, we can see that the resultant vector is placed in the hypotenuse side, which means the function we will use is tangent. So substitute the values. The opposite in y component is 5.91. Then the adjacent, which is the x component, is equals to 5.23 meters. So first, divide these values. So we will get 1.13. So to further express this, tan is equals to 1.13 meter. So we need to transfer this to the other side. So just simply type these values in your calculator. So the angle will be 48.5 degrees south of west. Therefore, Luna's resultant displacement is 7.9 meters in a direction of 48.5 degrees south of west, which is her position from her starting point. I hope you learned from this video. Thank you.